This single bug has stolen over $100 million from DeFi. And it's almost always preventable. It's called a reentrancy attack. It's been around since 2016, when it took down the DAO and split Ethereum in two. You'd think after almost a decade, developers would have learned. But every single year, new protocols lose millions to the exact same mistake. So let's fix that. By the end of this video, you'll understand reentrancy better than most developers who deploy to mainnet. Here's the core idea. Imagine a smart contract that lets you withdraw your funds. Normally, it does three things in order. It checks your balance, it sends you the money, and then it updates its records to show you've withdrawn. Sounds fine, right? But here's the problem. When the contract sends money to another contract, that other contract gets to run its own code first. And a malicious contract uses that moment to call withdraw again, before the first withdrawal finished updating the records. The contract still thinks you have a full balance. So it pays you again, and again, and again, draining everything. That's reentrancy, re-entering a function before it finished its first run. So why does this keep happening? The root cause is ordering. The contract sends money before it updates its internal state. That tiny window, between sending funds and recording the change, is the entire attack surface. And the reason developers miss it is subtle. In most programming languages, calling an external function is safe. But in Solidity, when you send tokens or ETH to another address, you're potentially handing control to code you didn't write. Code that can call you back. That's what makes blockchain different. External calls aren't just data, they're a handoff of control. The fix is beautifully simple. It's called the checks effects interactions pattern. Instead of sending money and then updating records, you flip the order. First, do your checks. Second, update your state. Mark the withdrawal as done. And only then, as the very last step, send the money. Now, even if a malicious contract tries to re-enter, the records already show a zero balance. The attack fails. There's also a second layer, a reentrancy guard, a simple lock that blocks a function from being called again while it's still running. OpenZeppelin gives you one for free. Use both. Order your code correctly, and add the guard as a safety net. This is in theory. In 2025, a protocol called Gempad lost $1.9 million to this exact bug. Their lock creation function made external token transfers before updating internal accounting. A textbook reentrancy. And here's the frustrating part. It was completely detectable before deployment. Automated tools flag this pattern in seconds. So if you're writing or deploying smart contracts, run a security scan before you go live. It costs nothing to check and everything to skip. I'll put a free scan link in the description. Order your code right, guard your functions, and don't become the next case study.